Hi, George Crump with VergeIO. Today we're going to dive a little deeper into our uh, uh, deduplication capability. Talked about it a little bit before, but it's very unique and so it deserves a little bit of extra attention. So what I have drawn up here is comparative environments. And if you look at dedupe, in most cases, it's going to happen at the storage array. VSAN has some capabilities. We'll talk about that. And of course, ours is integrated directly into our core VergeOS operating environment. So one of the first things to really understand is that our dedupe was built from day one, right into the product. Most storage systems added the dedupe functionality years after creation. It's a separate module, a separate process, it has separate metadata. And so all of that adds complexity to doing all the work that dedupe has to do. Now you can overcome this complexity, or the vendors can hide this complexity by throwing more processors at it, more RAM at it. But generally speaking, that raises your overall cost. The advantage of doing it from day one and integrating it into the same code is now it's all the same metadata, and I'm not having to kind of manage multiple metadata tables. And so it scales better. It doesn't require as much processing power. It doesn't require as much RAM. The second thing is, for the first time, we have a hypervisor aware and a network fabric aware deduplication algorithm. And let me explain what I mean. Most dedupe today is done at the storage system. So if you're sending some information to the environment, you insert dedupe into the process to identify redundant data, and then it writes that data to the system, right? Or many systems today write the entire data set here, and then as sort of a post-process, we'll do the deduplication, right? In both cases, well, in the second case, you're consuming, at least for a little while, extra capacity. In both cases, though, you are sending that whole payload to the SAN before it's deduplicated. And then when you go to recall from the SAN, it has to be run back through that deduplication algorithm to rehydrate it to send it to these whatever the application is. Now, again, it can be overcome with a lot of processing, a lot of RAM, but that adds to your overall cost and frankly just isn't very elegant. In the VSAN example, because VSAN runs as a separate component within the VMware stack, all the metadata processing is handled here. So none of this is really dedupe aware. It has the same challenges that a SAN would, an external SAN would. Now, what we did, like I said, it's integrated here. So when, as I shown before, when we have a chunk of data come in, what we do is we assign that data to a particular node. It'll happen kind of on a round robin basis. And the first thing we're going to do is look for redundancy. Well, all of these redundant segments, as they're processed by this node, all we do is update metadata, and then it doesn't travel across the rest of the environment. We don't impact other networks. We don't impact other processors, nothing. So it's much, much more efficient. And so that's one of the reasons we don't require the CPU utilization or resources and memory resources that other products do. So this integration makes a big difference as far as data transfer times and resource utilization. So it's a very powerful capability. Now, the last part is our global, the fact that it's globally aware. So let's take an example where I've got a remote site, a set of remote sites here that are maybe communicating back to the primary site for disaster recovery, things like that. And so you want these remote sites, if they fail, to come up in your primary data center so you can provide services to that remote site until the remote site is repaired. Well, in our environment, what we'll do is, of course, we've got built into the product the ability to replicate these and bring them up, leveraging our virtual data center technology makes it really easy, which we've talked about in other videos. But what we'll do is we will replicate this first site up, and the only data that gets transferred is the data that is at this site, but not at the primary, right? And so anything that's already at the primary doesn't get transferred. So this transfer is pretty quick. Now, when I go to the next site, what'll happen is, again, I'll do that replication, but now I'm going to benefit from the fact that whatever data is here and the data that was here that was already sent up. Well, in the case of remote sites, a lot of times they're very similar. And so this second remote site will replicate up very, very quickly. By the time I get to the third site, you guessed it, now things are going very quick, right? I'm replicating very fast because now I've got data sets from these, all three of these now. And so probably a lot of redundancy here. So this job will go very quickly. And then finally, when I get to this fourth site here, it might go so fast you don't even notice it, right? Because there's typically, as I said, there's so much redundancy in remote sites that you're just not going to see a lot of unique data. And so that's how that works. And of course, from that DR perspective, if one of these sites were to go down, very simple to bring this virtual data center or tenant up, give it an IP address, and then users can start logging into that as if they were sitting there. So very fast. We support BGP, so all that routing and things like that happens very quickly. So that's the deduplication, integrated from day one, hypervisor, network aware. Both of those cut down on resources, and then global. So ideal for disaster recovery sites as well as remote office, branch office type of scenarios where you want to be the primary data center and provide a DR site, if you will, for your remote offices. Thanks for joining us. I'm George Crump with VergeIO.